Okay, so hey, train your plants every day. Jordan Scoble coming at you from the STEM lab here. Now, I've kind of been working on one to get me back in the rhythm of a thing, and I need one that's a little bit more stable in its form to get back on the track for my STEM models and my Horseman Code one. Those are kind of in the quantum nature of a world, and you got to deal with a lot of heavy duty stuff that's kind of real hard to play some days, and figuring out the order and the position and stuff. I don't normally have too much of a problem with that. It's just, getting it going. And, once I get it going, usually I get the momentum and I'll crank out half a book or something like that. A lot of it's out there. You're just not quite parroting. I mean, you do have to make augmentations and adaptations to certain things to make sure that it all blends smoothly together in a universal set. It's a universal tool for the STEM model and to the code works, and I have to integrate all that together, and it's a multiple series of books and what have you. And sometimes it's just easier for me to kind of look at it from another perspective first and kind of hammer one out down that way. So I got one going here, and I'm going to get it rolling. Um, the information there I got to collect is, the same thing. I have to go off the internet, and I'll be getting some stuff from, what mathematics I'm using and some general frames that work really good. But I got to get back in the rhythm of taking the notes and making the note forms that are correct and just get my brain in the right gear for it, so that way I can just be intuitive to how things are going to connect and do that. And again, one of the better ways I do that is just to find one handy. Um, it doesn't need to be what this one's going to be for you guys, whoever's going to go out there and try to do this for the first time or the second time or the third time or whatever it takes for you to find the mastery where you just jump right into anything and do it. And really, there's no difference between these two things I'm about to talk about. But, when I want to do, it's just going to be practical for what I do at work, and maybe it'll help me out a little bit and other things. So I got an extra journal I've just been kind of floating around. This isn't one of my bigger ones that goes into the same set that's the rest of them, but it's the same kind of journal, and it'll make it look nice when you put them all together and things like that when I'm done with all of them. Obviously, I'll have the STEM book, my Swag Incorporated, General and Officers Training Guide. I'll have the code book that goes with that, which is kind of things you'll find into there. Obviously, I'm not going to have a full code set, but it has to deal with prime systems and what have you. There's one going to be just for psychology. It's 365 pages of just hammering it down. And you're going to find a lot of that seems really practical, like common sense stuff, but how you orientate that is a process all on its own, and it's a huge deal. And we're going to talk about that when I'm describing what I got to do for this book at work. I've done this several times before in very high-end processes and things like that, and we're going to get into kind of the details of it against other models that I've done, but this one's going to take it to a whole nother level where I'm really nutting and bolting. I'm taking the crowbar to everything and just tearing down my old wrecking bar I use at the saw there, and I'm just going to tear down that thing. And whatever's, rock solid bolted to the floor, we're keeping, and, we're just making sure that the mechanics of it, we're taking the wrench to everything and making sure everything else is tightened down in this process. Seems relatively straightforward. Believe me, it can get really difficult, especially when you're the handler trying to explain this information. Really critical. The old saying that goes with this is, if you really want to learn something, try to teach it. You'd be amazed how difficult of a task it really is. So this is going to be my trainer's guide for operating a gantry saw and being a mason behind the gantry saw as a sawyer. I haven't quite worked out the title of what that's going to be, the mason's guide to operate sawyer operating gantries, Italian gantries. I might have to get the name of the saw. This is basically a tutorial and hand-on. You'd think, well, that's pretty simple. Here's a button, it goes X up and down, Y left and right, and you couldn't be farther from the truth. As a general sawyer, yeah, that's all you're doing is cutting, sure. That is far from the tasks asked of me to do during the given day. And I look at that and I assume anybody that I would want to train, or if there so happened to be a reason why there isn't a person in there that day, that you have to be able to handle all the tasks that are given to you during the day. Unloading other saws, the 4 and 5 footer, are a huge part of this. Um, how you unload the block, lay down the block, lay down stuff, whether it be treads or whether it's a start of a pattern model into that system, chipping off the lips and bringing them over. You don't think about that. It seems relatively easy. The processing time is absolutely critical to understand these steps and to know the proper setup and what kind of station you might have. Your pallet layouts for things like running pattern and having a rerun pallet and recut, or your recut pallet and your variegated or full color pallet handy inside of whatever set that you're doing, which might go from 1x1s all the way to 3x3s or 2x3s. And inside that set, think about that. You got 2x3s, you got 6x3s, you got 1x3s. That's just the 3-footer length. Then you got the 2x2s, and you got you'd go all the way to 3x3, but 2 6x3, 2x2, and all of them. You have to pack that all into a given space, and the addition of a certain number of pallets can make or break you depending on what kind of cut you start with. Obviously, you're always going to start with the biggest and have the smallest, and sometimes leave the middle stuff out. By leaving that layout in your floor like that, you can actually achieve this, not bother with that, only have a small setup of something that comes off of a remainder of a cut by trying to chase the 2x3s on whatever cut you're making. Generally, you're going to get that, and given the slab that you're given, it's going to be the dictating factors of whether that's a 1x1 at the end, a 1x2 at the end, so why you have to have those. And those pallets contain more rock, so you'll be able to put more on them longer, and you need to chase them throughout the entire process unless you're just slamming rock of that size, which then it doesn't matter your slabs. Given the orders you may deal with, you may never know what an order looks like. What's a thermal top? You have to be able to read that. What's a pallet load? How do you set up a rock face in cut? You got to give it the addition on that cut. Just be able to look at that stuff first glance and make that note. Well, you definitely have to do this as a rock facing jig. And not only that, you're going to have to put in a pallet or a table to your pallet to be able to rock face this stuff. Thermal and tap and edges to be a finisher inside this set as well. Individually, they're all their own processes. You might only need to read certain parts of it, like on this cut, how do I, set up a stack on that table to run for pattern? Or if I miscut a thing, what happens when I forgot to negative it instead of positive it and starting in the back and then my saw went the wrong direction? How do I make the quick fix? How do you reset that? There's a couple different ways of doing that, and you have to be able to handle those things. If you were negative and you started this way, it's pretty easy. Just measure it down the distance, X out that first cut, and go continue with the remainder cut. So if I had an 18 and I needed a 1 and another 18 for some reason, there was some slag and junk inside the cut like that, I would just skip out the 118, measure from that cut with the blade, and go. If I'm going the other way with it, you can do it that way. It's a lot harder. You might be slightly off with your measurements if you're not very careful, but you can also put it to the cut, drop it inside that cut till the blade, like a CNC machine, just touches it, move it back and forth to make sure that amongst that skin or that edge cut and that middle cut, you bring it in there and you make sure that there isn't a lot of contact, because that's where the blade made no contact before. If you're riding it and it's moving as you're moving this, then obviously you're too tight, and that's going to skew that difference. When you go to move that, it's going to be too far. So what you do is you drop it down, you touch it, you make sure that it's in there so you can pass the blade without touching either side, because if you're touching the back, it'll roll. If you're touching this side, it'll roll. So once you get it lined up, tapping the X or Y button there, it'll slide through. You bring it back up to its 0 position, and then you use the gauge on the computer screen to tell you 18.19 given the curve of the blade. And that's going to put you right in your position where you need to be. Drop the cut from there. It goes a lot quicker than trying to drop that cut into that position again and run it again, or I'd have to run the full cycle and cut in air and then back up. I mean, if you're going to set it up like that where you had to do that anyways, or negative it from that position, think about that. It's going to cut air, and it's going to come back over, cut air again, and then start the cut. You are way behind the 8-ball at this point. Little things like that can make or break your sets. The little things like that is going to make and break whether, the floor space for everybody, the guys in the room, the guy unloading that saw for you, the big sets, whether the big saws, the 7, the 8, and the 11, are going to be able to put stuff on the floor for you, or you running one-to-one with the cycle like this. Some things you can't avoid. Every once in a while you're going to try to make a tread that didn't come out. You're going to get a lot of recuts. You're saving them all to the end so you can make it really efficient for yourself. When you go to put them all to the table at once and instead of just trying to fight one piece of pattern at a time that's real easy to kick, you have to run it a hell of a lot slower. You have to line that thing back all up, and you'll have to do that with every recut. It's easier just to save them all into a set as you're measuring them to put them on the table. Make sure you got all your 18s and stuff ready to go. It seems relatively simple when you're there cutting it. It's not. All the tasks individually are just a series of singular operations, A to B, which is a very simple thing. It's broken down that way, but to understand where you're positioned in that idea, have setup layups, have conditions where you're going to be thermaling your stock. You're going to be putting it to the table. You're going to be finishing edges on treads, and you're going to be reburning pattern and rerunning thermal stuff that already kind of come out reeded. You'll have to read that to make sure you're going to get a cut out of it. A tread will go back to, I cut it at 7 foot. I run a reed at the end of it. That top edge is good. How to read rock, how to play with jack, how to fix problems. What happens if you chip an edge? You got to flip that rock over, run the other side, make sure it's not on the side that you needed as the face, because you'll have to burn the other face as well. If you're aware of these things, you're going to be less likely to break them when you're putting them to the table. How do you put treads to the table without chipping them with the fork truck? How do you take treads off the table without chipping them, putting them to the pallet? If you don't know these little things, you're adding a lot of work for yourself. So, it may look very complicated and difficult, but once you understand this stuff up here, it's going to make the physical load you put to your body a hell of a lot easier. And then you're going to be running full tilt one-to-one with these systems, which seems like it can be a pretty extreme model of working and busting ass all day, but actually you're not doing all that much at all. Comparatively, if you weren't doing all those things, hammering through little procedural things, it makes your life way more dangerous. You're touching product 3 times more than you need to. That's adding percentageably to how many times it can bite you. Quality to the product. If you're touching it more and you have to do more work to it, chances are that it's not this refined, smooth process where it should come first time around, and therefore all these issues. And again, that goes with reading rock and reading your process, looking at all the points and the letters and the dimensions of everything you got there to have it spell out exactly what kind of setup you're going to need. Playing with your overburden problem of leftovers and garbage and stuff like that you can't use. How do you work all that into the process? Beyond all that, there's treads, there's pattern, there's how to set the saw, set the bottom limit, how to set the top limit, your left and right limits. Obviously, your cuts are going to give you the front to back limits that you can do. Knowing the table and what that table can cut, where it can cut, where it can't cut before it shuts off, how to fix it if you go too far, how to change blades, when to change blades, what blades are you using for pattern, what blades are you running for heading off block, what blades do you need for setting pattern, how do you set pattern, how do you measure out the cut in a block to do all those things. Seems relatively simple, and once you've been doing it for a little while, the hard method, it almost becomes second nature. But are you running them to those procedural systems because they're really all the same in universal field theory? How to set a tread is the same thing as running block. They're all the same cut, but the setup is completely different in the entanglement of unified field theory. They're all generalized by the note form, very special to how you work through this. So just some of the notes I'll be getting with. Catch you on the next one.